Okay, welcome class. Okay, friends, please help me take attendance on the Google Sheet. Then, please check. Max Grab, please help us take attendance on the Google Sheet. Okay, then everyone please check that you have received back the assignments. Okay, so go and watch the previous video. I posted it. So then back on JP things. We agreed Monday, right? Yes. So Monday we shall. Okay. So yesterday I alerted you, right, that I will ask students to present your work for the questions. Okay, seems like now we only have one taker for now. That's fine. Later I'll just pick a few others, present yours. Oh, Claire? Yeah. Can you get ready? Maybe you take some time to work. I'm going to walk around now, but everyone else does help me by later. Okay. Yeah. Right. So now. How about you can keep the paper is fine. Go from where? From down here. Cái tao phải rồi đó. Who wants to present 9? No, 9. 10, sorry. Question 10. PQ 10. I think I shall do PQ 10. What did I shall do? Okay. I think I should do PQ 10. I said on top of the other questions, right? I went to PQ 10 already. Yeah, your class is the fastest. 11 haven't, right? Okay. 11, any volunteers? Okay, or rather any volunteers, first come, first serve. First person to volunteer, you get to choose from 11, 12, 13, and 14. So if you volunteer later or you get selected later, you have less choices. Okay. Volunteer, yes, for what question? Okay, can you upload now? Thank you. Okay, 11 seconds, yes. 12, okay, upload. Yes, Joshua wanted 12 also. Now you do 13, thank you. You haven't do 13? The two of you who has done 13? Between the two of you who both want to do 12, any of you have done 13? Okay, thank you. Then Joshua, 12 lah. Okay, can. Okay lah. I'll take 14 lah. Okay, come. Okay. So the three of you please upload now so that later by the time Claire finish, okay, your work will be there already. Okay, then we don't have to wait. Thank you. You can submit multiple files, that's fine. Okay, come Claire. Hey. Can you come? Where should you stand? Stand at one of the screens so that you can point at things. Okay. I leave it to you which screen to point at. It's up to you to choose. Okay, so all the volunteer presenters, please speak in a volume that is audible. It's a very big room. If you want to borrow my mic, you can ask. Yeah. Okay. Please take it away. Sorry, can louder? Thank you. Okay. Let's continue. Shortest distance is magnitude of E over. Okay. Okay, next. Okay. Sorry, you said A dot N or B dot N here? B dot N, right? Okay. Okay, so let's look through again. Any comments? Part 3, Part 3 got comment, is it? Okay, part 1 and part 2, I think is fine. It's good that you observe since n is a unit vector, magnitude of n is 1, so you can simplify to modulus of d. Okay, so as a reminder, do we know what is the sign of d? Do we know whether d is positive or negative? We don't, right? So if we don't, we need to keep the modulus. Okay, because I noticed some of us like to drop the modulus after a few steps for no rhyme or reason. Okay, now this one, any comment? This statement here. Okay, there is very good effort in the phrasing lah. Okay, you say intersect R with position vector R. Okay, at least you never say the point small r. But this part here, you all know what this symbol means? Is parallel to. Okay, so I write L1 is parallel to L2. This symbol. This symbol is 3 words. It's not 1 word. Okay, so if you write it here, then I will read this statement as the line and plane are not is parallel to, so they intersect. Which is not very English lah. Okay, so use the word parallel itself. Okay, you may also want to include the point that b dot n is not 0, so the direction vector of the line is not perpendicular to the normal of the vector of the plane. Thus, the line and the plane are not parallel. Okay, yeah. So I'm not sure if you all noticed, but this problem is basically a generalization of what we have been usually doing for finding intersection between line and plane. So this is like a general formula. I give you any equation of the line r equals a plus cb and r dot a equals b as an equation of plane. You just use this formula, you will get. Okay, but we can go one step deeper. Okay, I think Claire, you can sit down. Thank you. Yeah. Okay, we can go one step deeper to think about in the case where the line and the plane do not intersect. What happens to the formula? So some step must not work, right? Which step is the one that will have a problem? Let's say the line and the plane are parallel. What is the value of b dot n? Zero, right? So then at this step, when I evaluate the dot product, this part here is going to be 0. Okay, so your t will be gone. Then it now comes to 2 possible scenarios. Either your a dot n value was equal to d or it's not. If it's not, then this equation will not hold. Okay, so no solution for t. That is the case where the line is completely outside the plane, it's parallel to the plane. Okay, and then there's another scenario where a dot n so happens to also have the same value as d. Okay, so in that case, it doesn't matter at all what's the value of t. Your a dot n is for sure going to be equal to d. This equality will hold for all values of t. Then what scenario is that? The line is on the plane. Okay, yeah. So your formula will fail because now you have an expression where the denominator here is 0 lah, in those cases. Okay, yeah, so something to ponder about. All right. Okay, have my brave musketeers uploaded your solutions? So I can see there are new solutions. Let's go in numerical order.
I just realized that I didn't do part 2.
Never mind, it's okay. Then you just present one. Okay, thank you. Okay, so now let us look at 11. Loretta, to set the context, can you just walk us through the question again first? Everyone look at your question. Sorry, can you say louder? Okay. So then the second part of part 1A. Okay, so what Lohita is doing here is so you found the scalar product form. Okay, so Lohita found the scalar product form of the equation of the plane. Okay, then you look for the intersection between the point, the line and the plane. Yeah, okay. Then. Okay, so you should get these three values now. Okay, but the whole process is quite long. Is there any other faster way? Did everyone do this way? Okay, I mean, this is the standard way to do it, lah. Right, you need the scalar product form, and I also mentioned once that we always rely on the scalar product form. Okay, but this is when there's actually an exception to the rule. Actually, what we can do, your equation of the plane as it is in vector parametric form, right? Okay, you can directly equate to the equation of the line. So meaning to say, for example, the I component will be 1 plus 2 lambda plus 0 mu equals to 1 plus t. Then you repeat the same process for each of the other two components. How many equations do we have? 3. How many unknowns do we have? 3. So are we able to solve them simultaneously? Yes. Okay. Do we need to solve them simultaneously by hand? Yes or no? Let's look at the question carefully. Do we need to solve by hand? Don't need, because that's fine. So what can we possibly get from the graphing calculator? You can use the simultaneous equation solver. Okay, then you immediately solve for the 3 lah. Huh? Okay. So did you say you didn't do part B? Okay. So part B, okay, never mind. We'll just go to part 2 first. So part 2 doesn't rely on part 1, right? Okay. So I hope everyone knows that the way the question is phrased now is for you to ignore the a equals 0 in part 1. Otherwise, the question cannot work. Okay, find the value of a such that L and P do not meet in the unique point. Okay, so now let's look at Novita's solution for this part. Okay. So you're saying the line cannot be perpendicular to the plane. Okay. Okay. Okay, thank you. Okay, so maybe let me just make a slight correction there. Okay, rather it's not that line cannot be perpendicular to the plane. The line, okay, the direction vector of the line, okay, cannot be, or rather it has to be parallel to the plane. Any other case, right? Maybe your line is coming in an oblique manner down. Okay, yeah. Then you will not be able to meet the line at more than one point. Okay, so the direction vector of the line has to be parallel to the plane. Therefore, it has to be perpendicular to the normal vector of the plane. Okay. Yeah. So the word, just I heard you say multiply, so just be careful. Okay, we should use the dot product phrasing. Okay, so let's look at part 2. Part 1B, sorry. Okay, find the coordinate of the planes such that the perpendicular distance from each plane to P is square root 11. So this one we have to have the normal vector or the scalar product form of the equation of P first. Okay, so P is, what's the equation? R dot 113 equals to 4. Okay, so now we know that, let's call them P1 and P2. There will be 2 lah, right? If you think about it visually, okay, there are only 2 planes that are parallel to P and of a distance square root 11 away. No other possible planes. Question is now, okay, what will be the values of their D? Let's call them D1 and D2. Okay, so we know that the distance between two planes, okay, can be found using this formula, d minus a dot n, right? D minus this, okay, so d minus 4 divided by the magnitude of the normal vector. Okay, so now what you do is you just simplify this. Okay, this is a good time for me to test you. Okay, I can multiply this over. What's the next thing I should do? Do I now say that d minus 4 is 11? This is only partially true, right? There's something else that might be happening, right? What's the something else? 4 minus d. This is exactly what happened to a lot of you in your Vectors II assignment part 1. You didn't consider the other case. Question 1, part 2. Okay, so please be careful. So d is 14 or d is -7. All right, so your conclusion, the planes have equation r dot 113 equals to 14 is one of them. R dot 113 equals to -7 is the other one. Okay, Ken? Okay, so now we go back to your friend's work. So Joshua's doing 12, right? Okay, Joy, what do you submit? 13, huh? Oh, okay. 14. 1, 5. Wow. Okay. Okay, Ken, we'll take a look later. Have you done 1, 5? Okay, never mind, I'll look through it. Okay, Joy, later I'll look through it. And I'll count this as student presentation. Don't worry. Okay. Yeah. Oh. Okay, come, let's look at this one. Question 12. Okay, maybe I show from the question first. Oh. Now we go into the world of the real world context problems. A very scary but exciting world. Okay. Let's run through the question. What's going on? Okay, wait. Okay, so now we look at Joshua's solution. How come I cannot? This thing doesn't zoom on, man. Okay, yeah. So we see from here. Okay. Okay, so just a reading exercise, right? Yeah, so part 1 is nothing much. Okay, part 2. Okay, so your answer 51.8 degrees. Okay. Okay, never mind, we move on first. Okay, so part 3. Okay, so this one just a very standard problem on finding intersection between line and plane. Okay, so we're not down on this. Okay, part 4. This one. Okay, and the last part. Okay. Any questions from the floor or comments? Let's go back to the start. Okay, I think part 1, no problem. Any comments here? Something disappeared. Yes. Okay, but Joshua got lucky lah. Because without the modular sign inside is positive. Okay. So in future, please be careful. You need to keep the modular sign throughout until you are very certain it's positive. Because you haven't evaluated, right? So you can't quite ascertain that it's positive yet. Okay, so you need to put in the module sign. All right. Okay. This one, nothing much to be said. This is similar to the previous problem that I discussed. Okay, so I will not go on this. Okay, the last one, any comment? Part 5. Is there another way to find OT? Or use this? Okay. Let's see. Wait, what is this question about? Finding, let me check. Find the shortest distance. Okay. Yeah. Any comments? So I think what Joshua is doing here is he found not quite the position vector of the four perpendicular, but from T to N. Okay, the vector itself. Okay, actually, what we just need to see is that you can find OT, right? You can use ratio theorem to find OT. So OT is 2/3 of OB plus 1/3 of OC. Okay, then after that, right, you just project OT onto N. Maybe I'll just write it down. Okay, thanks. Joshua, you can sit down. Okay. So OT is part 5. Okay, it's 2 OB plus 1 OC. You read the question, then you see why this is so. Okay, use the ratio theorem. This is 6.5, 4.52, right? Okay, then remember when I find distances only, I don't need to find the point. Okay, so the shortest distance from T to the plane, okay, is vector OT dot N hat. What is your N hat now? Your N, okay, is 0, 0, 1. Right, because we are looking at the plane Z equals to 0. So this will be the normal vector, okay? So now you just take 6.5, 4.52 dot 0, 0, 1. 0, 0, 1 itself is a unit vector already. Like that also can. Okay, thank you, Joshua. Okay, so now we go to the last question. Okay, getting very wordy. Okay, a water jet cutter uses a mixture of water and abrasive material to cut metals and stones. Okay. Someone's supposed to present, right? Come. I think this time you all upload as picture better. Also, PDF can also. So picture can see. Okay, so like what Isaac said, okay, find the two vectors parallel to the plane. Okay, continue. So this is a dot line. This is a dot line. Okay. Yeah, right clearly. Thank you. Next, part 2. From the nozzle to the laminar. Something seems a bit off. I think this should be 37 without the square root. Am I right? That's the magnitude. Okay. Oh, I see. Okay, yeah, so that's fine. Okay, anyway, yeah, so this one. Okay, I think it's okay. I think it's correct. Just that you need to, you should rationalize the denominator. You should rationalize. Yeah, so it should be correct. So if you rationalize, then you have 370 over 697, then whole thing times square root 37. Yeah, it should work out. Okay, so rationalize denominator. Okay, now we move on. Okay, so we use the formula for angle between two places. Okay, and yeah. So remember angles round off to 1 dp. Yeah. For degrees, radians we round off to 3 sf. Okay, part 4. Line of intersection. Okay. Okay. The line of intersection is the x-axis because so the question again. Okay, so we can observe right? The x-axis is on the lamina. The x-axis is also on the disc. Where is my disc? Disc. Okay, so you can say by observation, right? The two are they both contain the x-axis But your way of writing, I don't quite follow. What does this mean? Oh, the y and z are 0. Yeah. Okay, I think you may want to write a bit more. You want to say that the lamina contains the points 200 and 400. Therefore, the x-axis lies on this plane, on the lamina. And also, we know that the x-axis lies on the plane z equals to 0. Okay, can. So of course, the other way, the other way we can do is the conventional approach to get the scalar product form of the equation of both planes. Convert them to Cartesian equation, plug them into the 3C to solve. Okay, that's perfectly fine also. But of course, if you can observe, then that will be faster in this case. Okay, part 5. So the significance is in the diagram, right? Okay, so your it's 3 units. Okay, so look at it. The square dish rests on the wood block with thickness 3 units. Okay, find the equation of the opposite surface of the wood block that is not in contact of the disc with the disc. Okay, so the only contention here is why not 3 lah? Why -3, right? But then I think you have something lying above it already. Okay, there's something lying above it with a positive x coordinate, z coordinate. Okay, so it has to be z equals -3, not 3. 10. Okay, that's all. Thank you. Okay, let's look at 14. 14 is a conceptual question. Okay, I think yeah, I should not expect you to present this, but I expect you have tried it. Okay. Okay, describe the locus of R in each of the following scenario. Wait, no, there's a part before that, right? Okay, explain why the locus of R when R cross A is 0 is the line passing through points 0 and A. Okay, so this one, remember, when will two vectors have a cross product of 0? Parallel. So either one of them are the 0 vector or they are parallel. But if they are parallel, what can I say? R must be a scalar multiple of A for some lambda. But what is this? This is R equals 0 vector plus lambda A, right? Okay, so therefore, L or the locus is the line passing through O and A lah. Okay, because the direction vector is A and OA is equal to this. Okay, so A will lie on the line also. Okay, very good question. What is a locus? Okay, a locus is a collection of points all fulfilling a common property. Okay, so for example, if I say the locus of all the points that is 5 units away from the origin, then what is the locus? It's a circle. Okay, if you're thinking 3-dimensionally, then it's a sphere, right? Okay, so the locus in the xy plane will be x squared plus y squared equals to 5 squared. That's an example of what is a locus. Another example is here. Okay, the locus of all the points. So what is the common property here? The common property is all the points, their position vector, when taken cross product with A, will give us the 0 vector. That is what is meant by locus. Okay, so next, R dot A equals R dot B. Okay, what do we do here? You should put everything on one side. Okay, and what is this? This is vector AB. Okay, so this is a plane normal to vector AB. And what else? That's not enough, right? There are so many such planes. Give me a point containing what point? Containing what point? Origin. We've been through this before, right? Yeah, in one of the questions. Okay, next one. So you apply the same strategy. Okay, why like that? I better write below. R cross A equals R cross B. Write your tildes, please. So just like the very first part of this question, I can now say that R is parallel to B minus A. But if R is parallel to B minus A, then R is mu times of B minus A. So this is the line. What line? Containing O. Right, because this is 0 plus and parallel to AB. Okay, next. Okay, so same but different. And you will get the same conclusion. Okay, because line containing O and parallel to AB also is a line containing O and parallel to BA. It will be the same line. Right, it will be the same line. Okay, yeah. Okay, thanks for the question. Okay, so I was talking about part 3. So now this one, you also do the same thing. Like factorize like that, like factorize like that. Put on one side. But this one not so simple. Okay, this one now you have R minus A is parallel to B. See how I use this is parallel to. Okay, so in that case, R minus A is T times of B. So what do I get? This is the line AB. Okay, so see the difference. Just now that one is not a line AB. Just now this is AB, right? O is here. So I'm looking at this line. This was the line for the previous part. Now this part then is this line. That's why same but different. Okay. So you can only see why so after you have been through all these processes. So the trick, the strategy, I think is a very good strategy to remember. Factorize on one side. Change cross product equals 0 relationship into parallel relationships. Next, change parallel relationship into scalar multiple relationship. You see, I'm using this repeatedly. This strategy is the same. But you need to see once to know that you can do this. Okay, if not, it's difficult for you to see, oh, I can actually do this. Can. Okay. Okay, next. So I'm doing the same thing here. See, okay. Change to factorize one side. Okay. Use cross product equals 0 vector relationship, convert to parallel relationship. Parallel relationship convert to scalar multiple relationship. The process is always like that. For cross product, for dot, it works a bit differently. Because dot product equals 0 is not parallel, dot product equals 0 is perpendicular. Okay, last part. R dot A equals R dot B equals R dot C. Wow, why so complicated? Okay, actually nothing complicated at all. Actually, this one got 3, you can generate 3 pieces of information. R dot A minus B is 0. R dot A minus C is 0. So we are looking at a situation like this. Let's say this is AB. Okay, your R must be perpendicular to this vector. Okay, but then also perpendicular to this one. So means what? Is the locus a plane or a line? It's actually a line. Superficially looks like a plane because got the R dot N equals B like wow, this one very familiar like that. But the problem now is it's not only like this. I have R dot A equals to D for both two things. So it must be R dot N equals to D for this and also for this. Means what? Actually, this is just what? Intersection of two planes. Because it must fulfill the two conditions, right? But if you fulfill the two conditions, that means it is a line of two planes. Okay, so the line, what's the line? The line is contains line containing origin and is parallel to AB cross AC. Or you can say the line containing O and is perpendicular to shouldn't put here. Actually, the origin is here. Okay, perpendicular to plane ABC. Okay, so that concludes our discussion for Vectors 2. Next week we'll start on curve sketching. I will release on Google Classroom what I want you to do. Okay. Now I give you the assignment part. Please help your friends who are not here. So this one you submit next Monday. And it will have a lot of things, right? Okay, so I can start now. And let me go. Okay, so you can start now. So that because you also have to attend tutorials, right? Start now. And then you can ask. This is now. You want to follow this for